Hey everyone, welcome back to the AP Precalculus series powered by Let's and Bound. So in today's lesson, we will explore one of the most beautiful patterns in math, that is the sinusoidal function. And yes, uh, and today we will learn what makes a function sinusoidal, its key features, like many things, like 4 things we will be doing, and we will see what are they, and also how the sine and cosine exhibit the symmetric and periodicity. And then, of course, we will practice few problems and then we will wrap up for today. So be ready with pen and paper, take down the notes. It will be useful for you for sure, right? So what is sinusoidal function? Okay, so this is the math definition. Sinusoidal function is any function that involves additive or multiplicative transformations like horizontal shift, vertical shift. Multiplicative means horizontal stretch, vertical stretch. If anything it's done, you do for f of theta sine theta, those are sinusoidal function. Okay. The sine and cosine are sinusoidal because cos theta you can get it by an additive transformation of on sine theta. Correct. That's why this is the definition in our AP course description. But generally, a sinusoidal function is any smooth, like a wave-like structure. I mean the graph, something like this. Okay, it's smooth and it should have a regular pattern. Here, what I did this, yeah, it's a wave, but it's not regular, right? Here deep, here not that much deep. So it should have a regular pattern. That is maybe phases of moon, correct? Those are regular pattern. Okay. If it's third day of a moon, like a crescent moon, it will be of the same shape. It will not differ suddenly huge and suddenly small. Not like that, right? So this is and it should go on and on. So this is all about sinusoidal function, right? Now, the what we are doing, so sine and cosine both are sinusoidal, right? So already we learned about the parent function. Simply, what is sine theta? Why is sine theta is a parent function? And if you do transformation, yeah, you can do for here also. And cos theta, right? So these are the two main things for today. Now, this is the explanation of why, like sine theta, I apply an additive transformation. Theta plus pi by 2 means what? Sine theta minus pi by 2. That means I'm moving pi by 2 times like left side, right? Because of the negative. So we are taking care of this. And I got this dotted blue graph. It's nothing but your cosine graph. So sine becomes cosine after I applied an additive transformation, right? So this is how this blue curve is nothing but a cosine graph. Can you see? It starts from it starts from 1 and decrease, crosses at pi by 2, minimum at pi, again it level up, crosses at 3 pi by 2, 1. So this structure is cosine, right? And this is what the dotted one. So sine theta plus pi by 2 is same as cos theta. Sine and cos are additive, sine and cos are sinusoidal functions. Now let's see key features. There are 4 important things. Amplitude of a sinusoidal. So they will follow a wave pattern, sine and cos, right? Amplitude means the difference between the half the difference between maximum and minimum. So you should know maximum and minimum. Then difference them, subtract and divide by 2. Okay. So if this is your B, this is your A. So you just do B minus A by 2. For sine theta, for the parent function sine theta, the amplitude is 1 because maximum is 1, minimum is minus 1 divided by 2. The formula subtract, don't add it. Mostly we will do a mistake, so it's kind of average formula will strike our mind there. So it's B minus A by 2. Formula has a minus, your minimum is minus. So 2 by 2 is 1. So general form of an amplitude is A sine theta. Is there amplitude always 1? No, sometimes 2 also we might get. So that time it will be not that simply y equal to sine theta. It's something multiplied before the sine theta. 2 means the amplitude is 2. Or if it's minus 2 means the amplitude is modulus. Amplitude cannot be negative. So take the modulus. I mean the absolute value of it. Okay. Now, this same will hold for cos also. I did for sine, but everything is same. What is the amplitude of sine? Cos theta? 1. If it's a general form, you got y equal to a cos theta, the amplitude modulus of a, right? Now coming to period, yes, we discussed in our first episode itself what is period. The period is length of one complete cycle. For sine theta, the period is 360 degrees, or in radians, it's 2 pi. General form, yes, period also will differ. It's not always 2 pi. When we apply some multiplicative transformation, the period will get affected. Y equal to sine b theta, right? So that b will decide how the period, okay? So the period is OG period divided by the coefficient, whatever the multiplicator inside you did. Okay, so if it is in degree or in radian, it's 2 pi by b. This is an important one. And this is amplitude and period. I hope this is clear. And moving to next, frequency. Frequency and period are reciprocals of each other. Okay? So frequency is number of cycles per 360 degree or per radian. So for one per 2 pi radian. For one complete rotation, actually per 360 degree, our sine will complete one rotation mean. But if I do some manipulatives, before reaching 360 degree, it might complete like one pattern, two pattern also. So if it completes 2 cycles, that is the frequency. So 1 divided by the period. The reciprocal of the period is frequency. Our some functions might take before 360 degree. Actually, sine will take the one complete relation from 0 to 360. But now only a part is done. Half of the relation is due. Only at 720 it's making it complete means. Then that frequency will differ. Okay, it will be by half or something. Okay. So sometimes your graph will attain multiple cycles before reaching 360. Its own period. Okay, otherwise, even attaining its period, it won't complete its pattern, the second case. Fine. And last one is midline, the horizontal line halfway between maximum and minimum values. If you know maximum and minimum, just add and divide by 2. That is your midline. For example, y equal to sine theta. Maximum is 1 plus minimum is minus 1 divided by 2. 0 by 2 is 0. And y equal to 0 is your midline. That is x-axis. Okay. And the concavity of the sinusoid will change when it crosses the midline. Okay, when we discuss about concavity, this will be useful. For basic sine theta, the midline is 0, just now we did. General form is other than x-axis, some other midline is also possible, but the equation will go under this additive transformation. Y is sine theta plus d. Y equal d is your midline. So if I say y equal to 3 sine x plus 5, this 3 will help, this will be amplitude and this plus 5 is there, right? It is midline. Midline you should always write y equal to 5, a horizontal line. Okay. And I think we have discussed all 4 key features. Now, important properties, odd function, even function, we already learned, right? So let me recall. If a function is odd, f of minus x should be minus f of x. Then it's odd. If you do f of minus x and you get exactly your OG function, it's even. So now sine is an odd function. And odd function is always symmetric about the origin. Because sine of minus theta is minus sine theta. Minus theta will be in 4th quadrant. If you apply sine for it, sine will be there. But here on its quadrant of C, only cos will be positive, so sine will be negative. So sine of minus theta is minus sine theta, it's an odd function condition, right? And here it's represented as midline. Your oscillation, the wavy structure is based on this line. Amplitude is the distance between this to this midline also you can write. Or we already learned it's a difference of the maximum minimum and divide by 2. Or if you know a midline and one of the extremum, you can just find the distance, the length between your midline and the maximum or a midline and the minimum. And period is one complete cycle. Okay, so it takes this much like 0 to 2 pi to make one complete cycle. So period is 2 pi. Right. Same for, no, not same, side change will be there. Cosine function is an even function. It's symmetric about y-axis because you just copy paste this side and it will go like this and this will go like this. Exactly they will behave. And how we are telling algebraically, cos of negative theta is, so fourth quadrant, and it's cos thing. So it will become cos theta with a positive, right? So cos of minus theta is cos theta original function, so it's an even function, right? And it's symmetric about y-axis. Even all even functions are symmetric about y-axis. And this is the general form of sinusoid. Actually, we have to do some phase shift, vertical shift, those kind of stuff. But as of now, the terms we learned, right? A sine bx plus d. Additive adding d will represent midline. And b, whichever you multiply inside and outside. So that outside will give you the amplitude and take absolute value every time. And b, this will affect the period. You can find the new period using this value. And this is the formula. Right. Or you can write 360 divided by modulus of b. Fine. And here we go. Let's solve some questions. Given the function f of theta is 2 sine theta by 2, what is the amplitude? So we know as a sine bx plus d. This form we learned, but yeah, we will learn one more thing in transformations in detail way. So what is amplitude? Modulus of a. So modulus of 2 is your amplitude, which is equal to 2. Simple. And period of the function is, it's 2 pi divided by the value of b. I mean absolute value of b. 2 pi. And what is b here? This is your variable. So b is not 2, it's 1 by 2 because you can write 2 sine 1 by 2 theta plus 0. Okay. So 2 pi 1 by 2, that will result in 4 pi. And that's all they are asking for. But what is midline is my question. Midline equal to y equals 0. No constant added, so we can just put 0. And question number 2. A cosine graph has amplitude 3, period is 180. Write the function of the write the equation of the function. So y equal to something cosine a cos, amplitude and period they said bx. No midline, so I'm not using d stuff. Amplitude is 3, so your a is 3 cos dx. Okay, period is 180. I know period formula. Period is 360. I mean, since they given degrees, I'm going for this 360 by b. And period is 180 equal to 360 by b. And we just solve for it. B equal to 360 by 180. And you got 2. So that completes my equation. Y equal to 3 cos 2x. Okay. That's all. And now, the last question. The function f of theta equal minus 4 sine 3 theta minus 90 plus 1 is given. Identify amplitude, period, and midline. Actually, I want 3 times a sine bx plus d form. Okay, here a little change. Minus 4 sine, you take 3 common now, then it will become theta minus 30. Okay, this is what I'm going to consider as x. Theta minus 30 plus 1. So minus 4 sine 3 x plus 1. This way you can consider. And now we can easily find amplitude is modulus of minus 4. I mean absolute value of minus 4, which is 4. How will you find period? It's 2 pi. Okay, they give in degrees. So let me go with degrees. 360 divided by modulus. I mean absolute value. Again, 360 by, and this is your b. It's 3. So it's 120 degrees the period. And last one, midline. Midline is something added outside. So midline is y equal to, this is represent midline, y equal to 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1. 1 right? We solved all the three questions and it's a very simplest topic. So do watch the video if you have any doubts. Also revisit the previous topics. We are in 3.5. So revisit unit circle, reference angle, all those stuff, right? And here I'm giving you the bonus question. For A and B, find amplitude, period, mean, midline, and frequency. Okay. So yeah. And take a screenshot and type, give your answers in the comment section. I will be meeting you in the next video very soon. Until then, keep learning, keep practicing, stay curious.